AI Casino. It can hear, it can even speak. It's interacting with us in ways that feel, well, more human than ever before. This is the wild world of multimodal AI. And let me tell you, it holds the promise of an absolutely seamless, intuitive future. But it also opens the door to some new and kind of scary dangers. So to really get our heads around this whole promise and peril thing, let's just start with a simple question. I've got a question for you. When is a better remote actually worse? I mean, think about it. You take a TV remote, you add a bunch of cool new features, voice control, motion gestures, the whole shebang. It's got to get faster and easier to use, right? Well, you might be surprised.
Okay, so check this out. Let's look at the actual data from a study they did with elderly users. They tested 3 different remote control apps. First, you've got your standard, clunky, button-filled app. Slowest of the bunch, taking over 31 seconds. No surprise there. Then they brought in the new multimodal app with voice, motion, all the bells and whistles. And yeah, it was faster, around 23 seconds. But look at this. The runaway winner? The simplest bare-bones app that only used swipe gestures. It clocked in under 16 seconds. I mean, it wasn't even a competition. Turns out, sometimes less isn't just more, it's a lot more.
Which brings us right to our first big idea. The myth of more is more. This really gets at a huge challenge in how we design technology. We have this built-in assumption, right, that if we just cram in more features, more ways to interact with something, it's automatically an upgrade. But as that remote control study just showed us, sometimes more is just more complicated.
And here you can see exactly what we're talking about. On the left, that's the super simple unimodal app. It's just a clean swipe pad, that's it. Then on the right, you've got the multimodal one. It's got buttons plus voice commands plus motion controls. For this particular group of people, it was no contest. The elegant simplicity of doing just one thing really, really well was just way more effective.
So the takeaway here is crystal clear. For these users, simple was just plain better. Faster, more satisfying, the whole deal. The big lesson is that just because you can pile on more ways for us to interact doesn't always mean you should. The real goal isn't more features for the sake of features, it's about making things that feel intuitive to a human. But what happens when we actually get that multimodal design right?
And that brings us to the incredible flip side of this coin, the promise of multimodal AI. Because look, when this stuff is done right, the dream isn't some cluttered, confusing remote. Not at all. It's about an AI that just gets us, that understands us as naturally as another person would, through what we say, how we say it, our gestures, the whole picture.
This right here is the whole goal of what's called multimodal human-computer interaction. It's a mouthful, I know, but the idea is simple. It's about finally moving beyond the keyboard and the mouse. It's about creating technology that can actually read our body language, pick up on the tone in our voice, see our facial expressions, and have a real, natural conversation with you and your devices. That's the end game.
And listen, this isn't some far-off sci-fi dream. This stuff is happening right now. You've probably seen demos of OpenAI's GPT-4o. It can respond to your voice in about 0.3 of a second. That is literally the speed of a human conversation. It's incredible. And you look at the car industry, Nissan is using this tech to spit out design ideas 4 times faster than before. And companies like Stellantis are building smart assistants for your car that actually learn your daily routines. The potential here is just massive.
But here's the turn. Let's talk about the other side, the bias in the machine. Because for every one of those amazing promises, there is a serious, serious peril. The moment you give an AI eyes and ears, you also give it the ability to learn all of our worst human biases. And not just learn them, amplify them on a scale that is frankly terrifying.
This quote right here, from a study on AI that conducts video job interviews, just hits the nail on the head. What the researchers found was shocking. They discovered that when they started combining different inputs, looking at not just what a person said, but also their facial expressions, their tone of voice, the AI's bias actually got worse. It became less fair.
And here's the cold, hard data to prove it. So there's this legal standard for hiring called the adverse impact ratio. Basically, if the score drops below 0.8, it's a huge red flag for discrimination. Now look at this. When the AI judged people based only on their words, it passed the test, scored a 0.87. Pretty fair. But the second it started using visual cues, looking at their faces, their expressions, that score nosedived to 0.52. That's not just bad, it's legally unacceptable. It revealed a significant gender bias. Just think about that. Adding more data made the system less fair.
And the potential for harm, it goes way beyond just a biased job interview. This is the exact same technology that powers deepfakes. And the numbers here are just sickening.
An estimated 96% of all deepfake videos online are non-consensual pornography. It's become this incredibly powerful and just devastating tool for harassment and abuse. And the risk spills over into our personal security. Think about it. These systems are hungry for our data, our voice, our face, our private conversations. All of that becomes a goldmine for hackers. And the experts are worried. They're predicting that by 2027, more than 40% of all data breaches related to AI will come from people misusing these exact kinds of powerful generative tools.
So, okay, we're in a bit of a pickle here, aren't we? We have this disembodied AI just sort of floating in the cloud, and it's creating all these problems with bias and just not getting the context of the real world. This has pushed researchers to explore a really fascinating new idea, the next frontier, embodied AI.
And they're asking a pretty wild question. What if the solution to all the problems of a disembodied AI is to give it a body? Seriously, if the problem is that AI doesn't understand the world in a grounded, physical sense, what if we gave it a virtual body, or maybe even a real robotic one, to help it learn? That's the core idea behind embodied AI.
Okay, I know this diagram looks super complicated, but the idea behind it, this dual embodiment framework, is actually pretty brilliant. The theory is to make AI smarter and fairer, you have to ground it in reality. To do that, you give it two things. First, an external body, so it can actually interact with the world and learn about cause and effect. You know, if I do this, that happens. And second, you give it an internal body, a way to simulate its own state, kind of like a basic survival instinct. The big hope here is that an AI that learns this way will finally have some real-world context, and maybe, just maybe, it won't be as prone to all those weird biases we were just talking about.
So whether we end up with AIs and robot bodies or not, this all boils down to one single crucial word: trust. Let's talk about building a more trustworthy AI. Because if we can't trust these systems, all that incredible promise we talked about, it's just never going to happen. The big question is, how do we get there?
Well, the good news is there are concrete steps we can take right now to mitigate the harm. First, we have to build fairness right into the code from the get-go. We can use tech like digital watermarking, so we can always tell what's real and what's an AI fake. And this is a big one. We absolutely must have a human in the loop for the really important decisions. And finally, something that sounds simple but is incredibly powerful: data minimization. The idea is, if you don't collect a piece of sensitive data in the first place, it can't be stolen and it can't be misused. Simple as that.
And this really gets to the core of it, doesn't it? As Chief Data Scientist Donsha Carroll puts it, we humans just struggle to trust a black box. And can you blame us? The way these things think is often a total mystery. And let's be honest, their track record on being fair is spotty at best. If we're ever going to build real trust, we have to find a way to open up that box.
So this leaves us with the central question, maybe the question of our time. We're building AI that can perceive the world just like we do. The challenge isn't just about code and algorithms anymore. It's about us. It's deeply human. How do we teach these things our values? How do we build the right guardrails to keep them safe? How do we make sure that when our machines can see and hear everything, we can actually trust what they tell us back?